Data transmission. In modern networks, data are transferred using packet switching. In modern networks, data are transferred using packet switching. Messages are broken into units called packets and sent from one computer to the other. So messages are broken into units called packets and sent from one computer to the other. In modern networks, data are transferred using packet switching. So this technology is called packet switching. At the destination, data are extracted from one or more packets and used to reconstruct the original message. So at the destination, data are extracted from one or more packets. So data are extracted from one or more packets and used to reconstruct the original message. So this technology is called packet switching. Messages are broken into units called packets and sent from one computer to the other. At the destination, data are extracted from one or more packets and used to reconstruct the original message. Each packet has a maximum size and consists of a header and a data area. Each packet has a maximum size and consists of a header and a data area. It consists of a header and a data area. So what does the message packet contain? Packet contains a header and a data area. So data is not alone. It has some header in it. It has something called header in it. So each packet has a maximum size and consists of a header and a data area. The header contains the addresses of the source and destination computers and sequencing information necessary to reassemble the message at the destination. So what does the header contain? The header contains the addresses of the so it contains the addresses of the source and the destination computer. Source and destination computers and sequencing information means the numbers. In what order the packets are, the message is broken into packets and the packets have arrived at the destination. So this sequencing information necessary to reassemble the message at the destination. So this is necessary to reassemble the message at the destination. So what does the header contain in the packet? The header contains the addresses of the source and destination computers and sequencing information necessary to reassemble the message at the destination. So what is a packet? A packet contains header and data. What does header contain? Header contains source address, destination address, and sequencing information. Sequencing information necessary to reassemble the data at the destination. Necessary to reassemble the data at the destination. So types of networks. There are two principal kinds of networks: wire area networks WAN and local area networks LANs. WANs and LANs. There are two principal means main. There are two principal kinds of networks: wire area networks WANs and local area networks LANs. What are WANs? WANs cover cities, countries and continents. So large area of is covered under a WAN. So WAN covers cities, countries and continents. So WAN connects cities, countries and continents. So this is based on packet switching technology. So this is based on packet switching technology. Examples of WAN technology are ATM asynchronous transfer mode ATM and integrated services digital network ISDN. So what is a WAN? WAN covers cities, countries and continents. It is based on packet switching technology. Examples of WAN technology are ATM asynchronous transfer mode and ISDN integrated services digital network. LANs. LANs cover buildings, only buildings. WANs cover cities, countries and continents. LANs cover only buildings or a set of closely related buildings. Buildings are a set of closely related buildings. Closely related buildings. Examples of LAN technology are Ethernet, tokency, and FDDI, Fiber Distributed Data Interconnect. Examples of LAN technology are Ethernet, token ring, Fiber Distributed Data Interconnect FDDI, Fiber Distributed Data Interconnect FDDI. What are the examples of WANs? ISDN and ATM. ATM and ISDN are examples of WAN technology. Asynchronous transfer mode and integrated services digital network. What are the examples of LANs? Ethernet, token ring, and fiber distributed data interconnect FDDI. Ethernet, token ring, and fiber distributed data interconnect FDDI. Ethernet LANs. Based on a bus topology and broadcast communication. So Ethernet LANs are Ethernet LANs are based on a bus topology and broadcast communication. Broadcast communication. Token ring LANs. It is based on ring topology. So Ethernet LANs are based on bus topology and broadcast communication. Token ring LANs is based on ring topology. FDDI LANs use optical fibers and an improved token ring mechanism based on two rings flowing in opposite directions. FDDI LANs use optical fibers and an improved token ring mechanism based on two rings flowing in opposite directions. FDDI LANs use optical fibers and an improved token ring mechanism. So, token ring LAN based on ring topology, FDDI LAN use optical fibers and an improved token ring mechanism based on two rings flowing in opposite direction. So based on two rings flowing in opposite direction. So earlier we saw that Ethernet LANs are based on a bus topology. Topology is nothing but bus network. Bus network. So what is a topology? Network topology. Network topology is the arrangement of the elements of a communication network. Arrangement of the elements of a communication network. Network topology can be used to define or describe the arrangement of various types of telecommunication networks, including command and control radio networks, industrial field buses, and computer networks. So, what is a network topology? Network topology refers to the arrangement of the elements of the communication of a communication network. So, how the different elements are arranged in the particular network that determines that is what is called a topology. The network topology can be used to define or describe the arrangement of various types of telecommunication networks, including command and control radio networks, industrial field buses, and computer networks. So network topology is the arrangement of the elements of a communication network. How I need to arrange the elements in the network so that they can communicate easily within each other. So the how I can arrange the elements of a communication network so that there can be good communication between them or among them. So that is the network topology. That is called a topology. So here LAN technology examples are Ethernet token ring and fiber distributed data interconnect FDDI. Ethernet based on a bus topology and broadcast communication. Token ring LANs based on ring topology. FDDI LANs use optical fibers and an improved token ring mechanism based on two rings flowing in opposite directions. Based on two rings flowing in opposite directions. So Ethernet LAN, see you can see this is the bus topology. This is the bus topology. What is a topology? Topology is nothing but the arrangement of the elements in the network. How means a description of the arrangement of elements in the network. How I need to arrange these computers in this network so that they can communicate with each other. That is a bus topology. That is a topology. Ethernet is using Ethernet LAN is uses bus topology. So this is the network cable. All the computers are connected to the single cable here. This is called bus topology, shared bus. The bus is shared among all the computers. Bus topology. This is a token ring LAN. So computers are connected in the form of a ring here. Ring. Computers are connected in the form of a ring. So this is a token ring LAN. Token ring LAN. This is FDDI LAN. FDDI means fiber distributed data interconnect LAN. So computers are connected in the form of a ring with an additional ring, dual ring, that is called dual ring FDDI LAN, which has dual ring. So it is a, what is an FDDI LAN? Sorry, what does it use? It uses optical fibers and an improved token ring mechanism based on two rings flowing in opposite directions. So here, see in this token ring LAN, the direction is unidirectional. Means see there is an arrow mark also given here. So the flow is only in this direction. Flow is in this direction only, but in FTDA LAN it is based on two rings, flowing in the opposite direction. Flowing in opposite direction means, see one ring is, the communication is happening like this. This is the arrow's mark. Anti-clockwise, the communication is in the anti-clockwise direction. And in the second ring, the communication is in the clockwise direction. Sorry, this is the clockwise direction, the top one, and bottom one is the center ring is the anti-clockwise direction. See how does the clock move like this from 1 to 12. Clock movement is like this, so this is called the clockwise direction. So what is anti-clockwise? Direction opposite to the movement of the clock. This is anti-clockwise. This is the anti-clockwise direction. Okay. So network connectivity type, speed and transmission time for 10 MB, 10 megabytes. Network connectivity type, speed and transmission time for 10 megabytes of data. Telephone, which uses dial-up modem. Telephone uses dial-up modem. The speed is 14.4 kbps. K means kilo bps. So kbps means kilobits per second. Kbps means kilobits per second. So the speed of the dial-up modem is 14.4 kilobits per second. Transmission time for 10 megabytes of data is 90 minutes. Network connectivity type means the type of cable used. The type of cable used, or the type of connection used. What is a network connectivity type means? See, there are several types of network connectivity. including cable, dial-up, Wi-Fi, broadband, fiber and Bluetooth. So network connectivity is nothing but something which connects the thing which connects two different networks. It means I can use a cable to connect different networks, dial-up, modem, Wi-Fi, broadband, fiber and Bluetooth. So this is called the network connectivity. So dial-up modem, if I use dial-up modem, for example in telephone, the speed is 14.4 kbps and the transmission time for 10 megabytes of data is 90 minutes. So this is a dial-up modem. Dial-up modem. So if I use a dial-up modem, it is usually used in telephone actually. The dial-up modem. So the speed is 14.4 kbps and the transmission time for 10 megabytes is 90 minutes. Next ISDN modem. See, this is an ISDN modem. ISDN modem. In ISDN modem, the speed is 56 to 128 kbps. KB, capital K, small b, small p, small s means kilobits per second. Kilobits kilobits per second. ISDN modem is 56 to speed is 56 to 128 kbps, and if I want to transmit 10 megabytes of data, I need 45 to 12 minutes. It's based on the speed. For 56 kbps I need 45 minutes, for 128 kbps I need 12 minutes. At 128 kbps I need 12 minutes to transmit 10 megabytes of data on the transmission. So on the transmission line. So T1 connection. So this is a T1 connection. This is a T1 connection. See, these are all called T1. This is a T1 connection. See, Ethernet wire networks. So this is an example of Ethernet. Ethernet cable. So the speed is 10 megabits per second. I need only 9 seconds to transmit the data using an Ethernet connection. As the speed is 10 megabits per second, token ring speed is 4 or 16 megabits per second. The speed of a token ring is 4 or 16 megabits per second. So see here, this is a token ring. Token ring In token ring the speed is 10 megabits per second. I need only 9 seconds to transmit 10 megabytes of data. See here there is a difference. This is bits in per second. This is bytes. Megabytes. Fast Ethernet. The speed is 100 Mbps. Fast Ethernet the speed is in fast Ethernet the speed is 100 Mbps. 100 Mbps gigabit Ethernet. Gigabit Ethernet the speed is 1 Gbps. In gigabit Ethernet the speed is 1 Gbps on gigabits per second. What is a Gbps? Gbps means gigabits per second. Gigabits per second Gbps. ATM means asynchronous transfer mode. These are just in the last slides. Asynchronous transfer modes. Asynchronous transfer mode is ATM. In ATM, the speed is 25 Mbps to 2.4 Gbps. So 25 Mbps to 2.4 Gbps in ATM. In ATM networks, the speed is in ATM networks the speed is 25 Mbps to 2.4 Gbps. So which network connectivity uses ATM? WAN technology. What type of network uses ATM? WAN technology. WAN technology uses ATM. The speed is 25 Mbps to 2.4 Gbps. Interconnection. Networks of low capacity may be connected together via a backbone network, which is a network of high capacity such as a FDDI network, a WAN network, etc. See, networks which have low capacity means low speed. Networks which have a low capacity, low speed may be connected together via a backbone network which is a network of high capacity such as a FTDI network, a WAN network, etc. FTDI network, WAN network, etc. So what is a backbone network? Which is a network of high capacity means it can be used as a backbone network means a network of high capacity such as FTDI network, a WAN network is called a backbone network. So FTDI network and WAN network, this can be used to connect networks of low capacity. Networks of low capacity. See structure of a bus backbone. Slow networks are connected using high speed backbone networks. You can see an example here. This is LAN 1, LAN 2. It is connected to bridge 1, bridge 2 respectively, and LAN 3, LAN 4 are connected to bridge 3 and bridge 4 respectively. All these bridges are connected via a bus backbone. Bus is a network, as we already know, bus topology, bus network. So it is connected via bus backbone. Okay, which is high speed, which is of high speed. So networks of low capacity may be connected together via a backbone network, backbone network, which is a network of high capacity, such as a FTDI network array and a WAN network, etc. LANs and WANs can be interconnected via T1 or T3 digital leased lines. LANs and WANs can be interconnected. So LANs and WANs can be interconnected. LANs and WANs can be interconnected via T1 or T3 digital leased lines. LANs and WANs can be interconnected via T1 or T3 digital leased lines, DSL. So what is the short form for digital leased lines? No, sorry, this is not DSL. It's a digital subscriber line. So LANs and WANs can be interconnected via T1 or T3 digital leased lines. LANs and WANs can be interconnected via T1 or T3 digital leased lines. So this is a T3 dedicated leased line. What is a T1? T2 means it is nothing but the variation in the speed. So T1 is 1.544 Mbps bandwidth and application is compressed video. T2 is 6.312 Mbps. Application is broadcast TV quality compressed video. T3 44.70 Mbps. HDVT quality video transmission. T4 is 274 Mbps multiple video channel. So these are T1, T2, T3. So the dedicated lease line T3 like this T1. LANs and WANs can be interconnected using T1 or T3 digital lease T1 or T3 digital lease lines. See here router. So this router switch PC. So PC is connected to the switch. Switch is connected to the router. Switch is PC is connected to the switch. Switch is connected to the router. So and router is connected to the ISP infrastructure. ISP. ISP means Internet Service Provider. What is ISP? ISP is nothing but the Internet Service Provider. Internet Service Provider, that is an ISP. Internet Service Provider. See, this is branch 1 infrastructure. Similarly, we have a branch 2 infrastructure here. PC is connected to the switch. Switch in turn is connected to the router. Router is connected to the ISP infrastructure via leased line. Leased line may be T1 or T3. T1 or T3. Variation in the speed T1 or T3. So PC is connected to the switch. Switch is connected to the router. Router is connected to the ISP infrastructure via leased line. Digital lease line. According to the protocols involved, networks interconnection is achieved using one of the following devices. According to the protocols involved, networks interconnection is achieved. So networks interconnection, so interconnecting different networks is achieved using one or several of the following devices. So how do we connect different networks? It is connected using one of the following devices. Bridge, a computer or device that links two similar LANs based on the same protocol. So bridge, a computer or device that links two similar LANs. So two similar LANs means two similar LAN networks based on the same protocol. So bridge is a computer or device that links two similar LANs based on the same protocol. See the bridge here, bridge here. So bridge is connected to the hub. Computer is connected to the hub. Hub is connected to the bridge. So computer is connected to the hub. Hub is connected to the bridge. Okay. So bridge is a computer or device that links two similar LANs based on the same protocol. So router is a communication computer that connects different types of networks using different protocols. So bridge uses the same protocol, router uses different protocols. A communication computer that connects different types of networks. So it connects different types of networks. But here bridge connects two similar type of LANs. Two similar LANs based on the same protocol. A router connects two different types of networks using different protocols. Router connects two different networks using different protocols. So this is a router. So router is connected to the switch. Okay, switch is connected to the hub. See this diagram. So this is a bridge. This is a bridge. This is an example of a router network. All these are computers. Computers are connected to the. So this is a bus topology here. Bus topology. Bus topology. So this is connected to the bridge. Bridge is connected to another computer here, which is connected to a hub. See hub. This is the hub. Hub is connected to the switch. Switch is connected to the router. So here also two different computers are connected to the hub. Hub B. This is hub A. This is hub B. And hub B is connected to switch 2. So this is switch 1, switch 2. Switch 2 is and again connected to the router. So what is the order actually here? First is hub. Hub is connected to the switch. Switch is connected to the router. B router or bridge router. B router or bridge router is single device that combines both the functions of bridge and router. So B router or bridge or router, a single device that combines both the functions of bridge and router. See, we just saw that. So the bridge here is connected to the router via a hub and switch. So let us see what is a B router. So B router combines the functions of both a bridge and a router. That is a B router. Gateway, network device that connects two different systems using direct and systematic translation between protocols. So what is a gateway? Gateway is a network device that connects two different systems using direct and systematic translation between protocols. So gateway is a network device that connects two different systems using direct and systematic translation. Two different systems using direct and systematic translation between protocols. Direct and systematic translation between protocols. Gateway. So gateway network device. The switch or gateway.
You know what? Many people are stopping their SIPs. मैं बता रहा हूँ आपको क्या हो रहा है.
So network gateway. Server gateway. Local network. Local network. Local network. So gateway is a network device that connects two different systems using direct and systematic translation between protocols. Direct and systematic translation between protocols. So B router or bridge router is a single device that combines both the functions of bridge and router. Combines both the functions of bridge and router. See, for example, here this is the Toronto branch. This is the bus network, Ethernet LAN. So this is a Toronto branch. So this is the Ethernet LAN. Toronto branch is using Ethernet LAN network topology. This is Vancouver branch. Vancouver branch is using token ring LAN. Token ring LAN network topology. So this is a bus topology here, Toronto branch. Bus topology. Vancouver branch is using token ring LAN technology network. So there is a frame relay ATM here. What is ATM? Asynchronous transfer mode. Asynchronous transfer mode or transmission mode. See, it is connecting, router is connecting Toronto branch Ethernet LAN to frame relay ATM. See here this router. It is connecting Toronto branch Ethernet LAN to frame relay ATM, and gateway. Gateway is connecting token ring LAN from Vancouver branch. Token ring LAN from Vancouver branch to the frame relay ATM. Token ring LAN from Vancouver branch to the frame relay ATM. So this is a T1 line. See, there is another branch here. New York headquarters. New York headquarters. So bridge is connecting different devices here. So this is a bridge. So bridge or router B router. Bridge is connecting to a bridge or router. See, this bridge is connecting this network, a New York headquarters network to bridge or router. This bridge or router is connected to the another bridge or router, which is in turn directly connected to the frame relay ATM, which in turn is connected to the frame relay ATM. So there is one token ring LAN here, one token ring LAN here. In New York headquarters, both are there. There are two different networks here. Both Ethernet is available and token ring LAN is also here. Both these networks are connected. Both these networks are connected to the frame relay ATM. Frame relay ATM here via bridge or B router. So this is is connecting router is connecting token ring LAN. Router is connecting token ring LAN to bridge or router. Again, this bridge is connected to the bridge or router using bridge or router B router. See here, there are two different networks here itself actually. Both are bus topology only, but connected differently using bridge. So this network is connected to the frame relay via bridge or frame relay B router using B router. Again, token ring LAN is connected to the frame relay ATM's bridge or router via router. The Toronto branch, Vancouver branch, and network New York headquarters, all these are connected to the frame relay router using routers, gateways, B routers. So rest of the things I will continue tomorrow. If you like my video, please subscribe to my channel. Thanks for watching.